we're going to start our unit on circles. The first thing we're going to talk about is what is a circle. So a circle is the set of all points that are equidistant from a given point. So we have our point here, center C, and the circle is everything that is the same distance from that point C. All right, so the circle is actually this exterior line here. This would be the interior of the circle, and anything here would be on the circle. Then we have some special segments in a circle. So we have the radius, and the radius is anything from the center to the edge. So the endpoints are the center and a point on the circle. So CD and CE would both be radii. A chord is any segment with endpoints on the circle. So we have here segment AB, because point A and point B are both on the circle. That would make AB a chord. Same thing technically with segment DE, right? Because point D and point E are both on the circle. There is a more specific name for that segment, though, that is called a diameter. A diameter is the distance across the circle through the center, or a segment through the center with endpoints on the circle. Notice that the length of the radius is half the length of the diameter. We also have a line called the tangent. So the tangent touches the circle at a single point. That is called the point of tangency. The tangent line does not go through the circle, it just grazes it right there along the side. A secant is like a chord, except it continues. So a secant is a line that crosses the circle twice. So since lines do not have endpoints, it goes past it on either side. So line J would be considered a secant, and so would line K. So if we were to look at this diagram, we should be able to explain what each of these are. So I look at point F. Point F is here. Point F is on the circle, and it's on a line that just touches it. So I would call that the point of tangency. It's going to be a little slow here, guys. All right, point B right there is our center. Segment IG. Now, it's very important that this is a segment. If I look at IG, if I'm only talking about the point that starts here and ends here, that would be a chord. Whereas if I'm now talking about line IG, notice the arrows, we're talking about the actual line that passes through it, so that would be a secant. Oops, almost lost my C there. BF, segment BF starts inside at the center and goes to the edge. That would be considered a radius. And then segment DG has endpoints on the circle and passes through the center here at B, so I would call that a diameter. Line FJ, notice line FJ is up here. It does not go inside the circle, it just touches it at that single point, so that is our tangent. And then segment EH, E is on the circle, H is on the circle, that makes segment EH another chord. There's some other things we should know about circles. So two circles are congruent if and only if they have congruent radii. So these two circles are congruent if GH and JK are congruent. All circles, though, are similar, right? Because similar is described as the same shape but different sizes. There's only one shape per circle, so all circles are similar. Then we have something called concentric circles. So they are coplanar circles that have the same center. So circle A smaller with the radius of AB, circle A bigger with the radius of AC. All right, so like a target would be an example of concentric circles. So like we said before, the radius is half the diameter, or the diameter is double the radius. And then we have some formulas that we should probably already know, but I know we often get confused: circumference and area. So circumference is like the perimeter, and we could either use C equals 2 pi r or C equals pi d. Area, the one that we always want to shout out, is a equals pi r squared. We just have to remember that we're going to square our r first before we multiply by pi. Anytime they ask for an exact answer, they would want you to keep the pi symbol. If they want you to give an approximate answer, you would multiply that by pi. So just to start, we're going to find the radius of a circle that has a circumference of 18 inches. So we know that our formula for circumference, and there we're looking for radius, so I'm going to use the radius formula, is 2 pi r. They're telling me the circumference is 18. So I'm going to set 18 equal to 2 pi r. So from here, I want to get r alone, so I will divide both sides by 2 pi. And when I do that on my handy dandy calculator, I get that the radius is about 2.86 centimeters. Sorry, inches. All right, so you're going to try the next one. You're going to find the diameter of a circle with a circumference of 24 pi feet. So I want you to pause this to do the work, and when you're ready, you can restart it and you can see my answer. All right, so if you're back, you see that the diameter is 24 feet. On to the next example. Now we're going to look at finding the diameter of a circle with an area of 95 square centimeters. So we're going to use our area formula this time, and we know the area is equal to pi r squared, and they're telling me that my A is 95, so we're going to have 95 equals pi r squared. Now this time I need to get the r alone before I can take the square root, which actually means I'm going to divide both sides by pi. So we are going to have to use our calculators to do that. So if I do 95 divided by pi, I end up with r squared equals about 30.24, 30.24. And now I could take the square root of both sides. So r ends up being about 5.5. I think we're at about 5.499. What they're really looking for, though, is the diameter. We found the radius, so we're going to multiply this by 2 so that we can get a diameter of about 11.0 centimeters. Okay? So you're going to go ahead and try the next one. Pause it again, and once you have your answer, make sure you unpause, and you will see the correct answer. All right, if you're back, R is 4 inches. All right. The next one's a little trickier. It does have a bit of a bigger diagram. They're telling us in this problem the diameter of circle S is 30 units. So right away, I know that each of the radii of circle S is 15. So that takes me here from point C to point S is 15, as well as S to the end. It also tells me the diameter of circle R is 20 units. So if the diameter is 20, that means our radius is 10. So that's R to D is 10. The last thing they tell me is that DS is 9. So this little piece right here is 9. We want to find CD, and we see that CD is right here. If you remember back from chapter 1, the segment addition postulate says that any two segments together will equal their whole or their sum. So something plus 9 is going to give me 15. So I'm going to do 15 minus 9, and that'll allow me to say CD is 6 units. All right, so you're going to actually try the next one, which is very similar. They're telling you the diameter of this circle here, S, is 44 units. The diameter of circle R, this one here, is 28 units. And CD, so now this part between them, is 10. So you're going to find both RC and DS. So pause when you're ready, and when you're good to go, you can look at the answer. All right, so we get RC is 4 and DS is 12, and both of those are just in units. All right, so now we have a polygon is considered inscribed in a circle if all of its vertices lie on the circle. So here we have quadrilateral LMNP is inscribed in circle K. We also have a circle is circumscribed about a polygon if it contains all the vertices of the polygon. So basically now we have circle K is circumscribed about quadrilateral LMNP. So in our next example, we have a square with a side length of 9 inches is inscribed in circle J. So we know we have circle J. Ooh, it wasn't so bad. Circle J. And in this, we have a square. And we know that each side of this square is 9. What we're looking for is the exact circumference of circle J. So if I want to have that, I really need to know what the radius or diameter is. So if I were to draw one of the diagonals of my circle, I actually end up with a 45, 45, 90 triangle, right? An isosceles right triangle. And I know that the lengths of the legs are each 9. And if I know my hypotenuse equals the leg times the square root of 2, that means my diameter of the circle is equal to 9 radical 2. Now that I have that, and again, I'm looking for exact, so I'm not going to turn that into a decimal, I'm going to find the circumference now, and we're going to do, lost it, sure we're good, circumference equals pi d. We have d, so c equals 9 root 2 times pi, or pi 9 root 2. And our units are inches. All right, so that would be our answer for this problem. You guys try this one. Find the exact circumference of a circle with a circumscribed square with sides of 12 feet long. Again, pause, and when you're ready, you can view the answer. All right, if you're back, then we can see that it is 12 root 2 pi feet. All right, moving along. Now we have some of the stuff that's happening inside a circle. So we have a central angle is any angle whose vertex is the center. So point C would have to be the vertex of the angle, and the sides are radii. So angle APB would be a central angle. All circles contain 360 degrees, so if I were to add up all the central angles that are formed when I draw some radii, it should add up to 360. Additionally, we have something called an arc. An arc is basically an outer portion of the circle. So here they're telling us that in the same circle or congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So if I know that angle 1 and angle 2 are congruent, that means arc FG and arc JH or HJ are congruent as well. And adjacent arcs, much like adjacent angles, are two arcs in the same circle that are connected by an endpoint and do not overlap. The arc addition postulate is a lot like the segment or angle addition postulate. So I can find the measure of an entire arc by adding up the two smaller portions that make it. All right, so here in our example, we have, really they should tell us that RV is a diameter because that allows us to know that this whole arc here is half of the circle, or 180. So then I can add together these three pieces. So we're going to have our 8x minus 4, or 13x minus 3, and our 5x plus 5 equals 180. So if I combine my like terms, I end up with 26x minus 2 is equal to 180. So 26x equals 182. And when I divide that, I get x is 7. For the next problem, it's a little simpler. I just have to make sure I count this part as R90. And I have all four pieces should add up then to 360. So we have x plus 90 plus 40 plus 85 equals 360. So when I combine my like terms, I get x plus 215 equals 360. And now I subtract the 215, and I get x is 145. So now you guys can try the next ones. No diameters in either of them. Just find the value of x. We know that each circle adds to 360. Pause when you are trying them and restart when you have your answers. So if we restarted, we see for our first one, x is 140. And for our second one, x is 50. All right. The last bit about arcs is that based on their measure, we can call them minor, major, or semicircles. So the arc is always equal to the central angle that forms it. So arc AB would be x, the same as angle ACB. So if an arc is a minor arc, it's going to be less than 180 degrees. A major arc is going to be more than 180 degrees, and we have to name major arcs by 3 letters. They're going to have still the 2 endpoints, but they're going to contain another letter that the arc passes through. We could either look at it as whatever this bigger angle is, or 360 minus the smaller angle. A semicircle would be an arc where the endpoints are on the diameter. We're still going to name it by 3 letters. We're going to include a point it passes through, but the endpoints are the diameter, so then that would be 180, right? Half of 360 is 180. So in our last example, if we're looking for the measure of each of the arcs, we can find the measures of their angles first, and if we know the measures of their angles, then we can find those specific arcs as well. Keep losing my pens here. All right, so I know that BE and AC are both diameters. I could tell because those are straight lines that go through the center. So if this part's 180, 180 minus 63 will give me my 117 right here. I know that this is 90. Keep hitting things here. All right, this is 90. Together, these should add to the 117, so that makes that 27 there. And then these are congruent because they're vertical angles, so this would be 63 right here. So now that we have every single angle inside measured, we can find the arcs on the outside. So arc AB, 2 letters. I'm going to go the shortest way possible between those 2 letters, so that's going to give me that 117 degrees. And then again, 2 letters means when I'm classifying it is a minor arc. Now this one, ABC, has 3 letters, so it's either going to be a major arc or a semicircle. So I'm going to look at A, B, C. So A and C are the endpoints, and they are also on the diameter. So that's going to be 180. Let's start it right there. And that is a semicircle. I have to abbreviate these. DE, 2 letters, so I can already tell this is going to be a minor arc, but DE, shortest way to get from D to E between these 2, so that's going to be 90 degrees. And that, again, we said was a minor. Same with arc CD, 2 letters, shortest way to get from C to D here would be the 27 degrees. Another minor arc. AD, 2 letters, shortest way to get to AD. So now here I have A, here I have D. I could choose to go this way or this way. Both ways do pass through another point. But the shortest way to get from A to D is here. So we're going to go along the edge here, and it's going to be together the 63 and the 90. So 63 plus 90, and I get 153 degrees here for arc AD. Another minor arc. And arc EBC. So now again, this is going to be either a major or a semicircle, and I'm really going the long way. I'm starting at E. I'm hitting B first, and then landing at C. So what that tells me is I'm going all the way here, all the way through to there. So I could add up the 63, 117, and 63. I could take 90 and 27 and take it away from 360. Either way, I get 243 for that angle, or that arc. And that was then a major arc. All right, so for the very last set of examples here, the try, again, I want you to try. You don't have to classify them, but measure each of the indicated arcs. Note that LJ is a diameter, and so is HK. I would find all of your missing angles first before you go ahead and try to find the arcs. So again, you're going to want to pause this before you go any further and try them. And when you're ready, unpause, and I can give you your answers. HL was 58 degrees. JK was 58 degrees. LKJ, arc LKJ was 180 degrees. Woo. And arc LJK was 238 degrees. All right, that's our first lesson on circles.